Welcome, everyone. Thanks for joining us and thanks for being part of our community. My name is Ryan Heffernan and I'll be your host for today. A few reminders before we get started. If you have issues viewing the live stream during the presentation and are using the web browser version of Teams, just refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Those two things seem to fix most of the connection issues on our hosting platform. By the way, all these links I'm going to be referencing during my intro here are all pasted into the Q&A window if you want to click on any of them. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast. You can enable them by clicking on the CC button located at the lower right-hand corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Please be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get a lot of questions on these webinars and we will do our best to answer them all in real time. However, if we are unable to get to your question, you can post it afterwards at aka.ms/Azure Sentinel Community. If you're listening to this after the fact as a recording, that's a great place to post your question as well. We love to hear your feedback on how we can improve these webinars. You can give it to us at aka.ms/security-webinar-feedback. I would also like to invite you to join our community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can do at aka.ms/security-prp, requesting features, giving feedback, reviewing our product roadmaps, registering for events, or joining webinars like this. We believe the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. Today's topic is the information model, understanding and normalization in Azure Sentinel. Our presenter is Ofer Shezaf, who is a principal product manager on the Azure Sentinel team. So without further ado, I will turn it over to him. Ofer, the floor is yours.
Ryan, my pleasure. Oh, how did I get to the last slide? I wasn't going to finish, I was going to start. Here we go again. So as Ryan said, my name is Ofer Shezaf. Some of you may recognize my voice. I used to do a lot of webinars covering many topics around Azure Sentinel, and I created Azure Sentinel Ninja training by now nearly 2 years ago. I may have disappeared from you, and the reason is that in the last few months I've been focusing on the Azure Sentinel Information Model, or ASIM, our solution for normalizing the data within Azure Sentinel. And today is my opportunity to introduce to you ASIM and discuss how you can use it, what are the benefits. Let's start just now. What we will see today, what we'll hear today. First of all, I'll do an overview. I'll explain what ASIM is, a bit why normalization, and how do we implement normalization in Azure Sentinel. Normalization is about schemas, as we'll see, and then we'll talk about the available schemas that are planned for extending them. And lastly, we'll talk about writing queries using ASIM. You'll see why it's much easier and how life becomes a lot different for Sentinel users. This is the first part, the more general part. In 2 weeks, we'll have a second webinar that will focus on creating parsers for your custom sources. It complements the picture of ASIM and normalization, and it's well, more technical, so to speak. You'll be the judge whether you want to join or not. We'll also, if there are many questions today, I'll learn from your feedback, so please provide it, and I'll cover additional topics that we've missed today and were important in the next session. So ASIM overview. So we're using very loosely the word normalization. ASIM, Azure Sentinel Information Model, is our normalization implementation, and I wanted to touch base and make sure that we all understand what normalization is. So in a SIEM product such as Azure Sentinel, we collect security data. We collect it from many different sources, and each source provides the data in a very different way. Normalization is about making sure that all this data is converted to a uniform presentation. It includes parsing the data. It might come in very different formats, and ensuring that the results of the parsing, the sort of key value pairs you get, have consistent field names. So the key part is consistent, and also the values, and we'll talk about it more later on, are consistent. So you don't have a field that's the same field, but it's numbers for one source and labels for another source. Each major SIEM technology promises to normalize collected data. It's not an easy endeavor. I think that a lot of the schemes available today for normalization do not provide sufficient value and can do more. We are working to make sure that ASIM provides, to Azure Sentinel users at least, the best normalization possible. Importantly, ASIM is the Azure Sentinel Information Model. We try to make sure that we align with OSIM, which is an open source information model. We can't be identical. We have product consideration to use. For example, we use what's called Pascal case, as you can see on the right. The names start with capital letters for the field names, and OSIM uses a different format. But otherwise, we try to make sure that if you know OSIM, it's easier to use ASIM, and also try to listen. And we actually have later tonight, every month, I'm meeting the OSIM team to learn more, to get their feedback, to make sure that we address the community requirements. What are the goals of normalization in general and ASIM in particular? Why do we need to convert all data into a uniform presentation? So there are, generally speaking, three advantages that will really make your life with Sentinel nicer. First of all, we want to simplify the development of analytics by enabling source agnostic content. The idea is that you'll be able to develop, and in the word analytics, I don't just mean detection rules, I mean every type of analytics in the product. Some of it are things you can customize, such as hunting queries or workbooks, or activities in entity pages. Some you cannot customize, but we use normalization to make sure that we provide more capabilities. And we'll see that later on. The idea is that a rule, for example, detection, we're getting to the most basic example, will not cover a specific source, but will cover any source that conform to the schema. So write once, use many, very valuable. Now, this data does not have to be just out-of-the-box connectors. If you have your custom data that you send to Azure Sentinel, it's currently not used in the out-of-the-box analytics. You can convert whatever analytics is customizable, such as rules or hunting queries. You can convert to use your custom data, but it's work that you have to do. Using normalization, we have already started. You'll see that to convert our content to use normalized schemas, you'll be able to just write a parser for your data to normalize it, and then all the analytics in Azure Sentinel will be able to utilize your own data. And when I say your own data, it's sources we never heard about. And it's also, in many cases, your specific way to drive data into Azure Sentinel, even if it's, yet again, Windows events. Now, those two were about analytics, built-in content or the content you create. The third thing, which is, we'll see it quite a lot later on, is also simplify the analyst use of the data. So assume now that it's not a rule that a content engineer in the SIEM is writing, but rather an analyst investigating an incident and typing a query. Today, it's harder because you have to understand the specific source you're working with. What is normalization and ASIM enables is the analyst to learn once, understand the schema, and then regardless of the source, he knows how an IP address is called. So that's much nicer. So this is a big promise. My idea today would be to show you how we have started to implement that within Azure Sentinel. The guidelines, how are we solving this today? So, and the technical details will come in a couple of slides. So first of all, we are using query time capabilities. We'll talk about it. We are using KQL. It has the advantages that if you already know KQL, you'll find it easier to use. That said, query time does have performance impact, which requires me leading the project to optimize a lot. And implies also that we are starting slowly to roll out the built-in content that relies on normalization, and we start with those that we are confident will work with query time normalization. We also build it, and you'll see the next slide or the one after. We are expecting Sentinel to have in the future, hopefully reasonably near future, in just time normalization capabilities, so data can be normalized as it gets to the system. This mostly solve the performance issues, and we with the model that you see now, the schemas will be future proof. So they'll be the same. Whatever you do today to adjust to ASIM will work also when we can accelerate by doing some of the normalization at just time. For those that have large implementations, you know, the 1% with very large implementations that are worried about performance issues with the query time normalization, I'll mention today a lot of query time parsing is already done. Nearly all our new connectors use query time parsers. If they don't use query time parsers, then the query themselves, the KQL rules have to parse the data. There's nowhere around that. And usually the parsers that we create for normalization are more optimized for two main reasons. One of them is that we work hard to ensure that. And the second one is that they don't try to encompass everything that the source provides. We'll see it when we learn more about schemas. Normalizing parsers focus on an activity. So log in, not all of the Windows events. And we'll see how that works. In practice, it means that in most cases, we actually accelerate rather than reduce performance. So your workbooks will be just faster. Not always. Now, this is probably the most complex slide today. From here, it just goes downhill, it becomes simpler. It's sort of, after that, it's explaining this slide. But this is like every good talk, there needs to be an architecture slide. So this is this one. I'll walk you through it, and I'll use a pen, and I'll change the angle so I can write. So data always gets in through connectors. That's the nature of the beast. Currently, connectors write into three tables, and everything here in gray is no change. That's the way it is today, apart from the gray, which is future on the left. But some of the data is written into product-specific tables, AWS, CloudTrail, Azure sign-ins. It might be custom tables. Many of our newer connectors which use Azure functions write in custom tables. And it might be standard generic tables such as syslog or security events or common security log, which are hosting a large number of sources with very different event types. So they actually represent very different activities or schemas in the ASIM terminology. In the future, we are going, and that's sort of when we'll have in just time normalization capabilities. We also will introduce normalized tables that already are built according to the schemas that I'll describe today, but that's in the future. To normalize the data that just streams in, and one of the advantages of query-time normalization is that streaming in is easy. Write your custom collector, send your JSON in, the data is in. You don't have to worry. Now you can normalize. To normalize, you use, let me try to use a different method. Use a source-specific parsers that implements the KQL functions. So a KQL function is something that uses part of your query. It hides all the complexity of the parsing and present to you a normalized the data that you've collected in normalized manner. We'll see how it works in this webinar. We have for each source, for each activity, we have a parser. So for example, we'll have a sysmon process events parser. We'll talk about it. It'll filter the information from the event table where sysmon events are stored, and we'll parse it and normalize it into our process activity schema. So that if you're interested in process activity, you can just query this parser as if it was a table and get the data in an easy to understand way after parsing. So that's the first promise, but you want to be really source agnostic. You want the analyst not to know where the data was collected. Actually, it doesn't matter if the process data was collected by Sysmon or by Windows events or by Defender for Endpoint. It's just process data. He has to analyze if a specific executable was used on an endpoint. So he wants to look into process data. And the promise of normalization is that he'll just search for process information. So the source agnostic parser uses a union function to combine multiple source specific parsers and provide a view to the analyst or to analytics that's combine them all. And we'll see how that works later on. On the top, today, most of our queries and workbooks analytics are using specific sources. We've started to convert them so they use normalized parsers so that they can use a lot more sources as well as your custom sources. So this is the complex stuff. Now let's try to break it into pieces. Let's start with the parsers. I mentioned that parsers are stored KQL functions, and in a second we'll see how it actually looks in the workspace. How do you deploy them? You can search for those functions in the workspace. You can see them. You can see their code. But the easy way to deploy them is from GitHub using ARM templates. We are working on making sure that those functions are actually available in every workspace out of the box. This is yet to be done. For today, you'll have to deploy them the way that you deploy today connectors that use Azure functions or the way that you deploy today playbooks. The source agnostic parser, which, as I mentioned before, is the one that combines multiple sources. You can see it on the right here. It's just a union statement between multiple source-specific parsers. And the big promise here that beyond the out-of-the-box parsers that we provide, you can edit it and edit your own parser to it. And by doing that, ensure that all the analytics that we've built on top of the normalized schema work with your custom source as well. Let's move on and see how it actually works. So let's start with the documentation because ASIM at the end of the day is I'll trust my own page, I hope. ASIM at the end of the day is a lot of documentation. Schemas are documentation. So this page, which you can always get to using ak.ms/asim, S is Azure Sentinel, is the main Bible for ASIM. It includes, if you want to get to learn the details beyond my webinar today and the next time, read this article. It's not a short one, okay? And you see the same graphical slide. It's an old version. I need to update. We discuss the schema concepts. We'll talk about all that as we go through the webinar. I don't want to go here. This is the detailed part. The webinar would be an easier way to consume that. It also links to the specific schemas that we've defined. I did mention the process event schema, so I'll go into that. Each one of those articles is simpler. It's essentially a reference that tells you what are the fields that are available in this schema. We'll talk about those a bit later on, but still the reference is important. Once you know that, you'll see that the fields are very common between the schemas. They do not change a lot, if at all. We'll talk about their basics in a few minutes. Once you know those fields and you work with normalized schemas, you have much more access to all the information. How do you install the parsers? So you'll have them in your workspace. So if you go to the parser part, you'll see a list of the out-of-box or GitHub-based parsers that we already provide for the process information. We currently parse the Windows 4688 event and 4689 event for process creation and termination. We parse Sysmon event 1 and 5 and Defender for endpoint. We actually, I think that yesterday I also released the Sysmon for Linux parser which is nice because Sysmon for Linux is not out there. You cannot use it yet, but I wanted to be ready. It's in private preview, and we already include the parser for Sysmon for Linux. So let's go to the GitHub repository where you deploy the parsers from. It's open source. You, as usual, can read and get to all the parser details here. You also see them in the workspace. You can modify them. It's yours to play with. But the easiest way is just to deploy them to Azure. And I mentioned that it's not hard, but I do mention that we are working to make sure that even this step is our basic parsers are provided. That's a good question now. So about essentially where to deploy, we need to find how to find the location automatically rather than is this each time too? I don't know. Anyway, review and create. System will check that, and then you just deploy. And it takes a couple of seconds, but in a minute it will be there. And now, if I go to the workspace itself, I'll go again so you see how I go there, even though I probably have it open. If you recall, it was called Contours 77. And you can see those functions now. They're not a secret. They're here. And if I do IAM process, that's the name that they will start with. You'll see the functions. Okay. If you want, for example, if you go to IAM process create and I want to load the function code, you'll see exactly the union statement that I just described. If I go to the Sysmon one, which is pretty complex, create Microsoft Sysmon function code. It's the actual parsing and normalizing function. It's what we provided. It's not, by the way, if when we get to this next time, you'll see it's not very hard. You see that there are two parts here. One is parsing because this one is you need to parse it, and then there's just mapping. You know, it just field names and values, field names or change names. So it looks hard. It's not very hard, but we'll talk about it in 2 weeks' time. We'll get back to how to use those parsers a bit later in the presentation. Now I'll go into how you use out of box, because if you go back to the documentation, to the documentation and go back to the process event page, you'll see that apart from parsers, we also have out of the box content alongside with it. The hunting queries are usually still in the GitHub, so you'll have to fetch them from the GitHub. The analytic rules are actually deployed in the workspace. So if I go back to the workspace and I go here to analytics, and I go to the rule templates, and here I'll still have to search for normalize. Again, work in progress. We are working to make sure that there is a filter for that, but all those rules are essentially normalized rules. If you install the parsers, you can now activate each one of those, and you get the value of the normalization. So now, say a excessive LX domain DNS queries, which is a query we translated from the info blocks version, will now work for any DNS source that we have normalized. We normalized Microsoft DNS, Umbrella, and info blocks, and you can add your own. Actually, we did GCP as well, but the connector is not there yet. So again, we are before the connector, and we are working with partners. I hope that in a couple of months we'll have 6 or 7 DNS sources out of the box, and again, you can add your own. And since we are just starting, if you want to reach out and get help with converting your own, first of all, webinar in 2 weeks. Secondly, we are here to help. We want to learn how you, what are your challenges with writing parsers. We'll see how to convert existing queries, rules later on. We'll get to deeper technical details. Let's go back to the presentation. So let's talk a bit about the schema itself. We are working our way through the schemas. It's a large project. It's a very detailed project. There's a lot of thinking. We're at Parsers, but there's a lot of thinking going there. If you read the main ASIM document, you'll see that there's a lot of thought process around that. If you follow my blog, I started blogging after many years, which I didn't blog. I blogged on product features on the tech community, but now I blog on my personal blog because it's nearly philosophy. There's a lot of, if you ever went into a discussion about normalizing, it's theological. So a lot of work about it, but there's something important to remember about those schemas. Schemas do not represent connectors or sources, they represent activities. So sometimes it's roughly the same. Firewalls report network sessions. That's one-to-one. On the other hand, if you go to the authentication schema here, authentication is actually a very small subset of what's reported from each source. When you collect Windows events, you collect a lot of different types of activities. Just 2 or 4 of those events represent log on and log off, and you can set it to 8. So the authentication parser actually filters out just those events and provide any analytics just with the relevant events for, well, all the brute force detections in the world. Moreover, the authentication schema, we normalize to the same schema, Windows Sysmon and Microsoft Defender for Endpoint events, which are about the same material. They represent the same activity, but we also normalize to the same schema exactly AWS sign-ins, Azure Active Directory sign-ins, and Okta sign-ins. Now, this is an amazing advantage. If you now start to use our normalized detections, your brute force or identity theft detections will actually not just work on all those sources, they will work across sources. So if somebody is trying the same username across all those sources, you'll detect that, or will fail on Windows and succeed on AWS, for example. So that's a very interesting advantage. So until now, we covered network, which is network sessions, HTTP sessions, which is web servers, web security gateways, and as well as IPSs and NDRs. We covered authentication. We cover process and registry, which is after network authentication provides a sort of completes the EDR event schemas. I forgot to mention here, probably I need to add network schema supports also endpoints, so MDE reported events or Windows Firewall, for example. And we also did DNS. DNS is important because there's a lot of IOC matching, again, DNS sources when the DNS events present malware attempting to get to its command and control center. We are going to, I hope we'll have files available. It's a few days late. We'll do also file activity, which like authentication has the advantages of crossing between endpoint and storage. For example, we have a lot of rules about malware detection on endpoint based on file signatures or file names, etc. Now, those are not typically found on cloud storage, but now the rules will actually cover that. So if malware found its way, was copied to the cloud, it will be picked up there, which is interesting, even on SharePoint. And we have plans will continue, and your input if we've missed something in the existing or upcoming schemas is important. Yes, it's still a work in progress, though what we found out that out of the analytics we already do, the 6 schemas that we are releasing, including files now, cover, it's a 90-10% sort of thing. It covers a lot. What's in the schema, beyond names? You need to use it. So let's start to dive into that. First of all, there are common event fields that are there for each schema. They're usually started with the word event. The exception is device field, DVC, starting with DVC, which usually relate to the reporting device. So not the source or destination device, but the reporting device. There's something specifically important about those common events that are very important, and we take a lot of effort to not do typos. There is one here. Sorry for that. We strive to make sure that we normalize the values for those fields, and it's important. In the next slide, we'll see what is value normalization, and why is it important, very important. Event type is, for example, the activity you report. Event result is whether it's success or failure. You can see it, actually it's here. Those are always the available values for event result. Event result details is the actual what brought success or failure to be reported. So for DNS, which is a schema here, for example, it has to be the DNS opcodes. An interesting anecdote about that we found while doing our parsers is that some sources report DNS opcodes in numerical format because the DNS standard has the numbers, and some report in textual, in label format. Of course, to make sure that you actually cover actually the analytics is able to work correctly across sources, you have to decide which one you're supporting. So we make this decision, which is not reported here, so I'll have to correct the documentation here. Okay, a word about value normalization. It's important. So something that we found out and we are working, and when we'll talk about parser writing in a couple of weeks, we'll focus on that to make sure that parser writers don't miss on that. But I want you to be aware of that. It's also one of the reasons why writing the schema by itself is not enough. Focusing on good parsers and normalizers is the important thing. So for example, device action. Device action is a very important field. It depicts what the usually firewall are very strong about that, did with the packet or connection. And it's nearly the same, but not always the same. So you see here for checkpoint, they use access and reject. And Palo Alto still use access, but with a capital A. That's simple, just do case insensitive, but with deny instead of reject. So we normalize, we made a choice. For us, it's always accept and deny. Actually, the Palo Alto way, it's a choice. And we always normalize to that. And if you're an analyst, you know it's that. And for checkpoint, it'll be the same after normalization. Another example, I mentioned we did also DNS. Different DNS sources present the actual query, the actual domain to be looked up differently. The normal case is, as you would have thought, just the FQDN. That's easy. Windows debug logs, DNS debug logs have this strange format. We don't really have a connector that collects that, but your custom connector may do that. If you just collect the logs through a file collector, that's what you'll get. The 6, by the way, is the length of string afterwards, the 3, and the 0 is the terminator. So you have to convert it. You can't just compare it to an IOC. It will not work. And then syscompare just have this small dot at the end that will kill all IOC matching. Easy to remove, but if you don't know that, you will miss attacks. So that's why normalization is very important. We document that. We say that we want this format, and the parser we provide will always ensure that you get this format. The last example we'll actually see in real time in the demo that I'll do in a couple of minutes. Different sources, and apologies on Microsoft behalf for that, because all the sources here are for Microsoft, report registry events with a different name for the key. Windows uses registry user as the hive or prefix. Systems use HKU for the exact same thing, and Microsoft for endpoint uses HKey users. That's tough. That means that the analyst is confused. Maybe he's not that confused because he can sort of get things out, but your analytics is, if you use one. When doing that, we actually found errors in our own detections that because we did normalization, we were able to alert on and fix. We decided on one of those, the defender for endpoint, but it's a choice. So that's value normalization. It's important. It's a value we provide as part of normalization. It's a lot of work. It's something that missed a lot around normalization in general. We hope to do well. We need support from parser writers. So as long as we do them, it's fine. Third party will have to approve work, make sure they do their work right. Again, without value normalization, source agnostic analytics is close to impossible. So we discussed the basic fields of an event. We discussed value normalization, which is very typical to the basic fields. There are some schema specific fields. DNS is very typical of that. There are the DNS protocol fields, the query type, things which are about DNS. But beyond that, beyond a small set of fields, all schemas include pretty repeating fields which are describing entities. And these are tough. We'll see why. We have consistent way of handling entities in ASIM. You'll have to learn about that. There's also it also means that entities are more uniform across sources because we make sure they are. Entities include users, devices, files, processes, etc. We do document them as part of the schema. So the actor or target username fields do appear in the network schema, for example. We don't hide them. It's not that they have to look into an entity's resource. We may not document everything. For example, the DNS schema is about DNS requests. DNS requests usually come without a lot. No user information, no process information. Sometimes the source is able to provide, for example, process information if the DNS request is collected on an endpoint. In this case, there is process information that is useful. It's not part of the schema, but you can use the process event information documentation to actually find how the fields will look like. We encourage parser writers to, if the fields are not in the schema, to still maintain a consistency with other schemas that may represent the same information. So how are users or entities in general represented? First of all, one of the challenges is that there are multiple entities of the same type in each event. So for example, most events include 2 users. So they have a prefix. Those prefixes are, we try to make them intuitive. They are of course documented in the schema documentation. And we actually have, I can show you that if you go back to the documentation, we actually document, so we document what they mean in the context of the event. So what is the actor, what is the acting process? We try to provide you with stories around that so that, we need to make it easy for analysts to understand. Then we have identifiers. An entity can have many identifiers. Identifier is something that uniquely identifies it. We decided to have primary identifiers. For a user, it's a username and user ID. We do try to make sure that you also document, that the parser writers also document what is the username, what is the format. So there's a type field associated with it that gives a hint to what the username field has as a value. For an analyst, it usually doesn't matter. They understand immediately. They know what it is. I mean, it's an email. For analytics, it's very important. Instead of trying to analyze what it is, it's available out of the box. It makes writing analytics much faster. User ID is the same. The user ID can be an SID from Windows, can be an AAID from Azure AD, it can be something else. And we document how to do a bunch of those. If there's something else, we'll edit. Then there are just, of course, attributes to the entity, which are, additional values documented. You'll see what their names. And importantly, there might be additional identifiers that are not the main one, and we still have a way to document them. Before we get into more demos for the last 10 minutes, because it's important, a few additional words about fields. When you read the documentation for the schema, you'll find that there is, and I can show you that we have a class, whether it's mandatory or recommended or optional or alias. What are those? So mandatory fields must appear every parser has to parse them. You can depend on them being in your result set. That's important because analytics has to rely on that. Recommend fields are things that we recommend to have in each parser, but some sources may not have them. And therefore, analysts can assume they are there, but if you write analytics, you need to write analytics around that to check if the value is there, and handle the case differently if it's not there. And then there are many optional fields. The schemas tend to be long. Don't assume that all information is available there. Lastly, there's aliases. Aliases are a usability feature. We do call for different fields to have 2 names. I think it's always up to 2 names. Sometimes because it's it's shorter. We tend to have in every schema a device field, a user field, a process field, an IP address field, so that it's faster. You don't have to do source user name. Okay, the alias will represent the most intuitive field which belongs to this area. So the user that we assume you're looking for. In analytics, use the full name. An analyst, the alias is there for him to make it much faster. So aliases are really an advantage that analysts can use when working. There's always a user in the schema. It's the user you think it is. You have a user. That's in contrast to my big discussion about complex way to represent entities. Don't worry, there is a user field. Okay, let's talk about writing queries. I'll show one slide. No, let's start. I don't have a lot of time, so let's start with the demo. So, it's here. So I already prepared the queries here to save on time. And let's see. I used the registry normalization schema. It's an easy case. Okay, so let's start with the Sysmon events for registry updates. They are in the event table, and there are events 12, 13, and 14. And let's run them. I'm using 5 and 4 days ago because that's when I have events for available. I check that. And if we take one, okay, we'll see that there's actually nothing here that helps us, because Sysmon events are really not parsed. It's not just about normalizing. It's all here in the event data field. That's not really useful for you. Now, if I use directly the registry event Microsoft Sysmon parser and run it, you'll see that I already got a lot out of the parsers. The event data parameter XML is still there, but you also have the actual action that was done. You have the acting process name. You have the registry key. Now that's an important thing here. If I go here, it should be hard. I won't try to do it now. You'll see that in Sysmon, I'll show it later on in Windows events. It's the same. So you actually have the fields available. You didn't just gain the fact that they're normalized, you actually got them parsed, which is important. So with this parser, you can use Sysmon much more easily, which is great. Now let's go to security events. Events 4657 is analogous. It's the registry update event within the Windows security event stream. Let's take it. This one is easier. It is more parsed. It's not as bad. Okay. You do have the registry key, but it's called object name. So it's hard for an analyst. Now, and it's different. It doesn't work. You can't try the same analytics. Moreover, the value type is, well, a code. What's 1876 means? That's not easy. So while the information is a bit more accessible, the user SID is there, it's not really easy to use. Let's use the same exercise and use the parser, the normalizing parser for Microsoft Security Events Registry. It's the same events, exactly the same events. But now if I open that and I look into that, I'll see that, you remember the code? It now appears as the original subtype, okay? The actual event type, event type is registry value set. So I looked it up and I normalized it into one of the values allowed as part of the schema. And you see that? Remember that in the previous set it was, I forgot to keep it, it was very different. We normalized it into the registry key. First of all, we call it the registry key. and registry modified for the updated value. It was called very differently in the Windows event, and we normalized the registry value. So now it's uniform with the sysmon event. Okay, and the value type, the 1876, now it's reg D word, so you can understand it.
Hey, Ofer, sorry to interrupt. Is there any way you can show the full query or tell people where they can get these queries? Because they were saying how they can't see the entire KQL query.
I see. So I actually, it's a. Let me elaborate. You see the entire. Thank you for the question, Ryan, for raising that. The query is full. I'm hiding nothing. Beyond the parser, there's the parser which I mentioned how to deploy when we start in the first demo. Okay, it has content. It's important. It's in the GitHub. Okay, I can go to the GitHub again and show you where it is. Let's go here, and you remember let's go to the registry events. So I mentioned here that here's where you deploy those registry events. Oh, sorry for that. I'll go to the GitHub directly and I'll fix the link later on. My bad. So the parsers are here. Okay, you can look at the values here and you can learn how it works, but you don't have to. That's the important part. If you go back to the query, what you as a user will always use is just that, as a black box. So I'm showing all the query. That's the magic of things. You don't have to do anything else. What this parser, this view of the table provides you is documented in the document I just showed. So very good point. Thanks for raising it. I hope that made it clear. In essence, all you need is the 3 liners I'm putting here, or the 2 liners in this respect. If I go to device registry events, that's the defender for endpoint table. This is probably the best out of the box presentation of registry events. It's pretty good. I mean, maybe not selling anything, you should start there and use it. It's still not normalized. The names are different. It doesn't conform to the other ones. So what we do is we have a parser for that as well that will parse the same so that the names, and again, it's a black box. It does the work for you. You can look. It's not a secret. I can actually, you can actually see it also here if you want. So I can go here and go and search for IAM registry. And for example, the sysmon one, I can load the code here so you can see it here. So that's the code that was deployed. But again, it was deployed black box for you unless you want to really learn, which I would really appreciate, and find the bugs. So when I run Vim registry event Microsoft 365D, I get the same defender for endpoint event, but normalized with all the right names as with the other sources. Lastly, to finish the discussion, I can always use IAM registry, not the long ones. That's probably what everybody should start using, okay? And that will just combine them all. They'll bring in all the registry events I have in a uniform format. I didn't want to show the same events again, so I'm just counting to show you that it actually brings all 3 of them. So they're all incorporated, they're all presented to the user as one. If I want to do a, for example, IAM registry, or registry key has, I can do it, it'll search in all registries or all sources and find nothing, hopefully. Let's see. I'm not there. I should have prepared something more meaningful. And that exactly, this way you can search across all registries, across any source. Lastly, to wrap up this part and show you again, going a bit into the function source, which we were interested in, if I go into IAM registry here, and I pick the main one, which I just used, you see it's just a union function. If you create your own parser and edit here, my own parser, and it adheres to the same rules, okay, you can save, you can actually update the function here. I will not do it now in order not to change things. I don't have Azure Parser. And then immediately your own source with your own parser will be included in all the analytics using normalized data. So a fast route to a lot more value from your own data within Azure Sentinel. I think that I wrapped up for today. I'll show you one last slide, which I jumped over before. This is an example of detection that we actually converted. I don't know. I'll do something else. Sorry, I'm looking for the best use of the time, your time. Let's look into how we can actually modify an existing rule to use normalization. So I'll search here for an info blocks. It's a DNS server rule. And I'll use it here. And I'll create a new rule out of it. Now, of course, everything is quite the same, but if I want to modify the logic, I can go here and I can change it to use, of course, I need to know the normalized data. I need to change not a lot of things. IAM DNS, like IAM registry, is the main parser for DNS data sources. I don't need this line. This line was where we are more optimal. This just makes sure that from info blocks only the DNS events are selected. Response code, I need to know that it's event result details. Very different, but that's the standard. It's always that. It's a common field. Again, response code. Client IP would be a source IP address. IAM DNS. I don't need this line again. And source IP address. Source. And that's all. So I know my schema. So for me, it's pretty easy. And I was able to convert a rule in 5 seconds. It will take more to you the first and second time, but it's not hard. And now it's not just info blocks, it's any DNS source, yours or other, which is great, or custom. While we are here, I want to show something which you just need if you didn't know about it. Still, alert details. Did you know that you can actually change the alert name these days? So it's dynamic. So this alert, as far as I recall, was the standard title is excessive NX domain DNS queries. Okay. But I wanted to reflect first the IP address, second the actual source that found it. So what I can do here is I can do here from source IP address. Leave it at that. Now this would be the alert name presented in the incident screen. Not related to normalization, but great to know. It's much more useful to the analyst to get in the incident list a list that has value in the incident titles. So that's as a tip, unrelated to normalization might be useful to you. Anyways, picking my topics, I think that it's a good time to allow you for a few questions. I think there were a few. Brian, you're on. Anything that you want to raise out of the Q&A channel?
Yeah, we've got several questions around performance. You mentioned minimal performance impact. Can you give a little more detail on that, or maybe explain why the performance impact is so minimal?
So the performance impact is there. There are two areas to mention around that. It's a good thing that I'll cover more next time. First of all, we do parsing anyways for many sources. And if we don't do it as a parser, all our connectors gallery is full of please deploy these parser buttons. We do this part of the query. A good example would be the Sysmon one. You saw my Sysmon parser, Yuval's, our Sysmon parser. Every alert that's built on top of a Sysmon parser has a Sysmon parser in it today. R is around 4 times faster than what is usually found there. We have the chance to centrally optimize the parser and make sure that we update it to the best we know all the time. So you just won. It's not always the case. Sometimes the original is very easy and normalization takes time. So it's a win and lose game. Sometimes you win, sometimes you lose. We tried to limit today with detection rules, those that we convert, just those that take up to 1 day of information. We believe that this will work for essentially all customers. Okay, if there are 14 days history to look at, we know that there'll be a small percentage of customers where those rules will not work for. Again, those are just optional today. You don't have to use them. Keeping that in mind, there are the standard rules and the normalized rules, which cover more sources, provide you with more value, but may not always work. Did not discuss today, but we'll probably be ready with that by the end of August. We are also developing a method to do parameter parsers, which will enable to pass to the parsers filter options. Those will be less transparent. What I showed you today was no change for analysts, just use normalization. This will require understanding a bit more. You'll essentially run the IAM registry parser, but pass a parameter doing the initial filtering. With those, we can ensure that performance will usually be always better than today, but it's a bit less transparent. If you have performance concerns and you are in the audience, I mean, and especially if you're a larger customer, I mean, 95% of our customers will never hit any performance challenge anyways. I'm happy to have an offline discussion about your specific situation. Yes, thank you. Good question.
Great, thank you. We've got several questions around the cost. Can you speak to that?
Oh, that's a good one. I like questions where there's no cost. Beyond that, since Azure Sentinel charges for ingest and not for processing, and since ingest did not change any at all, and query time implies we are doing normalization and processing time, we may add cost to Microsoft, but as customers, there's zero change to what you'll pay.
Great, thank you. Take one last one here. How does it work in MSSP mode, i.e. only one Sentinel office for multiple clients? Could you create a playbook and apply to all customers?
It's one of those that I'll probably have to take offline. The main reason is that the main question is how it should run, okay, but there are subtleties. We use standard KQL capabilities here, but when essentially playbooks don't run KQL normally, so the question is sort of out of context. When you run alert rules across, it should work. But if you have a very unique way to run your artifacts across customers, if you hit on a challenge, we'd love to work with you to solve it. I guess that's the best answer. Offhand, I can't think about a specific challenge, but there might be. MSPs are always a more challenging case.
Okay, great, thank you. All right, I want to thank everyone behind the scenes who answered questions on our webinars. I want to thank Ofer for an excellent presentation. Most of all, I want to thank all of you for joining us. We hope if you want to look for the recording, you can find it at aka.ms/security-webinars. We'll have that up as soon as we can. And that's also the great place to look for our upcoming webinars. So we hope you'll join us for those. Thank you, everyone, and thanks for being part of our community.